All right, folks, we are going to continue to dive into reaction writing. Now, we can actually predict our products based on the type of reactants that we have. Okay, so this is going to be the meat and potatoes of this unit. Okay, the actual prediction of products based on what your reactants are. Okay, and the first one we're going to look at is we're going to look at synthesis reactions first. Okay, now if we remember, synthesis is where we take two small things and we stick them together to make one product, okay? So this says write a balanced reaction for the reaction which will take place when potassium reacts with chlorine gas, okay? Now notice the only thing that it gives us is it tells us that we have potassium and it tells us that we have chlorine, okay? Now, do you see a problem right this moment? Because I do. Actually, I see a lot of problems, but I see one big problem, okay? Potassium is K, chlorine is Cl, but don't forget that chlorine is one of our 7 diatomic elements. So I can't just call this Cl, I have to call it Cl2, okay? Now, I also need state symbols. Now, it doesn't tell me that this is solid or liquid or gaseous potassium, but when I look up at my periodic table, I see that potassium is black on the periodic table, which means that it is a solid at room temperature. So I'm going to go ahead and put an S right there, okay? Now, it does tell me that my chlorine is chlorine gas, so I can go ahead and add G right there, okay? So now I put in my arrow. Now I have to predict what my products are going to be, okay? So I'm taking potassium and Cl, 2 individual elements. The only thing that I can do with those is stick them together. Okay, I can't do a single replacement because I don't have an element and a compound. I can't do a double replacement because I don't have 2 compounds. Okay, all I can do is stick them together for a synthesis reaction. So this is going to form potassium chloride. So now we got to remember that potassium has a +1 charge and chlorine has a -1 charge. So when I stick those together, it's just going to be KCl, okay? And so now I also need to figure out what my state symbol is going to be. This can be tricky, all right? Because KCl is an ionic compound, we know that ionic compounds have very high melting points and boiling points, okay? Since it has a very high melting point at room temperature, all ionic compounds are going to be a solid at room temperature, okay? And it's because of that extremely high melting point. So, question, is this finished? Do we have everything done? The answer is no, because it's not balanced, okay? So I've got a K here, 2 Cls, 1 K, 1 Cl. So I know that I need to go ahead and add in a 2 right here and a 2 right here, and now everybody's happy. Okay, so my last question is this redox? Well, remember from earlier, I said if you have an element by itself, it's going to get an oxidation number of 0, okay, and 0. And then when it's in a compound, it's going to have its normal oxidation number from the periodic table, so +1 and -1. So did our oxidation numbers change? Yes, they did. Since oxidation numbers changed, we can say that it is indeed a redox reaction. Would you like a hint? Okay, I will happily give you a hint. All of these are going to be redox except for double replacement. Okay, boom, I said it. There it is. It's out there now. Okay, they're all going to be redox unless it's a double replacement reaction. So yeah, you can do all this 0, 0, +1, -1. You can do all that, or you can just say, oh, is it a double replacement reaction? No? Okay, then yeah, it's a redox. All right, let's look at another kind of reaction. Where's my marker thing at? Here we go. All right. Next, we're going to look at decomposition. So this is where you start off with a compound and you break that compound down into smaller pieces. Here's a hint. If you ever have only one reactant, you know for a fact that you're going to have a decomposition. Okay? Decomposition is the only one that has just the one reactant. So this is write a balanced equation for the decomposition of solid lead to oxide by heat. Okay, so lead is Pb and oxygen is O, and it says that it's lead to oxide. Well, I know that that means that lead has a +2 charge. I already know oxygen has a -2 charge, so it's just PbO. Okay? So now this says that it is solid, so I'm going to put my state symbol of S. Okay? Now, there's something special about this one. It says that it decomposes. Oh yes, by heat. Okay, I knew that that was there. By heat. So what I need to do to show that this is decomposing by heat is I'm going to draw my arrow, but on top of my arrow, I'm going to put a little triangle. Okay? The triangle means that it's decomposing because it was heated up. Okay? So what I want to do now is I want to go ahead and decompose this. So I'm going to decompose it into its individual elements. So what I've got is I've got lead, and I've got oxygen. Okay, now oxygen, is it just O? No, it's one of our diatomics, so it's actually O2. Now, we need to know what our state symbols are going to be, so when we go back to our periodic table, I see that lead is black, making it a solid at room temperature. Oxygen is red, making it a gas at room temperature. So that tells me exactly what my states are going to be. Okay, so lead is solid, oxygen is gas, okay? And I could say, oh, my oxidation number is 0, and -2, and +2. My oxidation numbers change. Or I can just say, oh, it's not a double replacement reaction. So is it redox? Yes, it is. Okay? That, my friends, is how you do a decomposition reaction. Let's take a look at a single replacement reaction, and that'll be the last one for this video. A single replacement reaction is where, remember, we've got a single element and a compound, and then we switch the partners, okay? So that's going to be what we're looking at here. So this says a piece of zinc is added to a solution of silver nitrate, okay? So I've got zinc. Zinc is a metal, so it's a solid, okay? Plus silver nitrate. You know what? We didn't balance that last problem up there. We did not balance this. To balance it, we've got to do 2 and 2. Okay, sorry about that. Just remembered that. Couldn't leave it alone. All right, zinc plus AgNO3. All right, so now we need to do our switcheroo. Oh, and it says it's a solution, so this is aqueous. Okay, so remember, we're predicting what the products is going to be. I have a single element, I have a compound, so I know that it's going to do a switcheroo. Okay, now the question is, who switcheroos with who? Okay, here's the way you're always going to tell. You want to the one that's going to switch is going to switch with the one that's most like itself. Okay, zinc is a metal. Zinc forms a cation. So therefore, zinc is going to switch places with the other thing that's just like it, the other metal or the other cation, whatever you want to call it, okay? So what's going to happen here is that zinc is going to switch places with silver, okay? So we're just going to do a little switcheroo here. So now our products are going to end up being silver, which is a solid, of course, plus zinc nitrate. Now, zinc nitrate, remember, zinc is N, Zn, nitrate is NO3, but zinc has a +2 charge, nitrate has a -1 charge. So I need 2 of those nitrates. So now, is this balanced? Zinc is good. Silver, 1 and 1 is good. Nitrate is not good. Okay, I've got 2 nitrates over here, 1 nitrate here. So I'm going to do a 2 here, and now I've got to have a 2 here. Okay? Now, zinc nitrate, how do I tell you this right now? We don't know our solubility rules yet. We may be giving you some solubility rules. Let me check on that real quick. You know what? I'll tell you about solubility rules in class, okay? Nitrate is always soluble, okay? So what that's going to tell me is that this is going to be an aqueous solution, okay? Remind me to show you that in class. I will absolutely be thrilled to show you that in class, okay? Now, is this a redox reaction? Well, is it double replacement? Nope, it's single replacement, meaning that it is indeed redox, okay? Or, once again, you could do the assign oxidation numbers 0 and +1 and 0 and +2, and then see that they change, okay? Or just say, oh, is it double replacement? No, it must be redox. Okay, that's it for that. For this one, we'll do double replacement and combustion on the next video.